Hi guys, welcome to Algorithms Made Easy. My name is Khushbu and in this video we'll see the question best time to buy and sell stock part 3. You are given an array prices where prices of I is the price of the given stock on ith day. We need to find the maximum profit that we can achieve given that you may complete at most 2 transactions. You may not engage in multiple transactions simultaneously, that is, you must sell the stock before you buy again. Let's see the example number 1 wherein we are given the prices and the explanation states that buy on day 4 at price 0 and sell on day 6 at price 3, which is this transaction, and then buy on day 7 at price 1 and sell on day 8 at price 4. So this is this transaction. If you do a total, you get 3 plus 3, which is 6, that is the output. So in example 1 we did 2 transactions. Let's see the example number 2. In the example number 2, the array is given in an increasing order, so we can just buy this stock at 1 rupee and sell it at 5, which gives us the highest profit, which is of 4 rupee. The example number 3 has a decreasing array, which means that no transaction will give us a profit. So we are not going to buy or sell the stock and our profit remains 0. So now with the examples it is clear that we can have either 0, 1 or at most 2 transactions to find the maximum profit that we can achieve. So let's go ahead and see how we can solve this question. When there was a single transaction allowed, which was in the part 1 of the question, what we did was we found out the minimum and stored it. And then at each step we used to find the maximum profit that we could achieve by considering the minimum that was the buying point and maximizing the profit by finding the maximum value at which we can sell the stock. With this approach, our output would have considered this particular transaction. Now, when we say that we can make at most 2 transactions, it means we can either have 0, 1 or 2 transactions. So looking at this graph, we can make 1 transaction for this particular range and the second transaction in this particular days. This will maximize our profit and that's what we want to achieve in this question. If we see here, we have 2 transactions, transaction 1 and transaction 2, which is dividing our sequence into 2 parts. And these transactions are the transaction that are giving maximum output in these 2 different parts. So we can consider these parts as left and right. So for a given point, if I am considering or if I am dividing my sequence on day 3, then I need to find out the maximum profit I can achieve from day 0 to day 3 and the maximum profit that I can achieve from day 3 to day 6. Combining these 2 will give me the answer for this particular question wherein I am making at most 2 transactions. For that, what we are going to use is bidirectional dynamic programming. As the name suggests, it is going to have iterations in 2 directions, one being from left to right and the other being from right to left. And since it is DP, we are going to store intermediate results of the maximum profit we can achieve till that particular day. So let's take this example, which is the prices array, and we'll take a left array, which is our intermediate result to store the profit that we are achieving when we are iterating from left to right. Over here, we are also going to have a variable which will store the minimum price, that is the minimum buying price. Initially, at 0th index, the profit will be 0 because the most you can do is buy at 3 rupees and sell at 3 rupees. And our minimum gets updated to 3. Moving ahead, when we come to this particular index, now we are going to see if my minimum is changing or not. If my minimum changes, I'll update that minimum buying price in my min variable and I can find out the profit, that is the maximum profit till the current index. So that maximum profit can either be the profit that I have already observed previously or the profit that I will make by selling the stock on the current price. which will give me the profit of prices of I minus min, which is the buying price. Currently for this particular index, since this particular price is equivalent to the minimum price, this is going to be 0 because it will be maximum of either 0 or 3 minus 3 0, which gives us 0. Moving ahead. Now I have a higher price. My previous profit was 0 and my current profit now becomes 5 minus 3, which is 2. If I see the maximum profit, it will be either the max of 0 or 2, which gives us 2. Similarly, I'll go ahead and check for this particular index. Now since my buy price is 0, which is lesser than the previous buy price, which was 3, I'll update the minimum variable. That is, I can buy lowest at 0 rupees. Considering this, the profit becomes 0 for the current transaction and the profit that I have already seen previously was 2. So I just take the same value and put it in the current index for profit. If you do continue this till the end of the array, you will get the profit that you can achieve by traveling from left to right on each and every day. Now we have the left array, we need to find out the same thing while starting from right to left. So we'll take a right array and we'll start from the end of the array. Since we are starting from the end of the array, we will now have the selling price. That is going to be the maximum price at which I can sell the stock, which is currently 4, that is value in my prices array. And now as I move ahead, I need to find the maximum profit that I can achieve by saying that this is the maximum value at which I could have sold the stock and the current prices of I being the buying price. So when we go over here, my sell price is 4, my buy price is 1, and my profit would become either the maximum profit I have seen previously or the profit from the current transaction, that is from buying at this particular price, which will give me 4 minus 1, that is 3 as the profit. Moving ahead, if my buy price now becomes 3, my profit is reduced to 1, which I don't want to take because I already made a profit of 3 rupees from the previous transaction. So the maximum profit was already 3. So I just added 3 over here in this particular index. Similarly, when you do this for all the other indexes, you will see the right array filled in this particular way. Now, let's see what all these components define. If I take this particular index, this 2 is telling me that the maximum profit that I can achieve till this point when I am starting from day 0 is 2 rupees or 2 units. While this 4 corresponding to the same index in right array will say that the maximum profit I can achieve in the future starting from this point till the end is 4. So at this particular point, if I see the maximum profit in this area and the maximum profit in this area is nothing but this 2 and 4. So from the two transactions, I can maximize the profit up to 6 rupees, which is the maximum that we can achieve. So this is one of the way of solving this question. Now I would like you guys to pause the video and try coding this approach by yourself. If you get stuck, refer to the coding part that I'll be showing now. So let's go ahead and code this approach out and then we'll see another interesting approach to solve this question. Let's take a few variables that we'll keep handy, and we'll also have a base condition, that is if n is 0, return 0. And now let's write down the bidirectional DP logic over here. First one is from left to right and second would be from right to left traversal. Let's write the left to right one first. Initially we'll need a variable min which will hold the minimum buying price, and that price is going to be nothing but the price on day 0. After that we'll start looping and we'll start our loop from index 1. In this loop, the first step is going to be update buy price, second is calculate current profit, third is fill the left array. So let's start with step 1, which will be If the current price is lower, we update the min. The profit will be selling price minus buying price. Sell price is the price for current index and buy price is min. So over here, the profit at current index would become the maximum profit that I can attain till now. So that can be either the previous profit or the current profit. The same thing we need to do for right as well. But for right, we will take a max which is equal to the selling price, and that would be initially equal to the value at last index of the prices array, and we'll take a for loop starting from second last index. Over here again we are going to have 3 steps. The first is update sell price, second is calculate current profit, and third is update the right array. So let's start with the first step. If prices of I is greater than max, update max. Now current profit is nothing but the sell price, which is max, minus buy price, which is prices of I. And third is update the array, which will be maximizing either the profit that we have seen earlier, that is right of I plus 1, or the current profit. Now that we are done with this, we need to iterate over both these arrays and find out the maximum profit from 2 transactions. For that, let's take a variable max profit, which is initially 0, and max profit will become the maximum of either the max profit or left of I plus right of I. That's it. Return max profit and we are done. Let's hope we haven't made any mistakes. And we have. Let's run it again. It's giving a perfect answer. Let's submit this, and it got submitted. The time complexity for this approach would be O of 3n, which is equivalent to O of n, because we are having 3 for loops, 1, 2 and 3. The space complexity is going to be O of 2n, or which is equivalent to O of n for these 2 arrays. So that's about this approach. Now, how can you find this in only one pass? So let's see that approach. So in this approach, we are going to see the one pass simulation. We can say that this particular question can have 4 different actions. Buy of transaction 1, sell of transaction 1, buy of transaction 2 and sell of transaction 2. Let's keep these points handy. That is buy, sell and profit, buy, sell and profit. And let's take an example. Suppose I am giving 2 coins to buy 1 stock, which is the buy of transaction 1 at cost C1. Now when I am selling this stock, I am getting an additional 3 coins. So these 3 coins are nothing but profit, and my sell price becomes C1 plus P1. Now let's see the transaction 2. When I am doing the second transaction for say some amount X, the amount that I am actually paying from my own pocket is 1 coin over here for buying it at cost 4. Why only 1 coin? Because these 3 coins were from the previous profit. I used the same profit and gave 1 more extra coin to buy the share. So this effective price for me that I had to pay from my own pocket was nothing but the cost of the second transaction minus the profit that I got from the previous transaction. So this was X minus P1. Now when I sell this share, I am getting some more profit, right? And then the entire profit of this transaction, if you see, is nothing but this transaction, that is the sell price minus the effective cost of buying this particular share, which was nothing but X minus P1. So my entire profit after both the transaction becomes Y minus X minus P1. So now at every given point in time, we are going to maintain 4 variables. which is the buy price of first transaction, which would be the minimum buy price. The profit from the first transaction, the buy price or the effective buy price for the second transaction, which is nothing but the number of coins that I have spent from my pocket to buy that share, not including the profit from previous transaction. And lastly, we'll have the profit, which is nothing but this. That is the profit from both the transactions together. So now my buy price for first transaction is always going to be the minimum price at which I can buy a stock. So for that, we can have a formula which is nothing but either the previous buy price that is already there with me or the current price on which I am there. Second thing, the profit. This profit is the maximum of either the profit that I have seen earlier or the current profit, which is nothing but the sell price minus buy price, considering that I am selling the stock at current price. Third thing is the buy price for second transaction, which is nothing but my effective buy price or this x minus p1. So that is going to be equal to the minimum of either the buy price that I have seen earlier or the current one, which is nothing but price of I minus this profit of transaction 1, that is x minus p1. This is the formula that we have written over here. The last thing is profit 2, which is the profit from both the transactions. This is going to be the maximum of the profit that we have seen earlier or the profit when we are doing the current transaction. So the current transaction profit will be nothing but the sell price at the current price minus the buy price, which was my effective buy price for the second transaction. That is y minus x minus p1. So y is my sell price, x minus p1 was this that we calculated already, so that is buy price 2. So now we know from where we are getting this formula. Let's see one example with this approach. So let's take this particular array, and this is the table that we have. Initially, the buy prices would be maxed out and the profits would be 0. Now, starting from index 0, my buy price 1 is minimum of either my buy price or the price of I. Initially it was max, so minimum of both these is 3. Profit over here is 0 because if I do the sell transaction at this current price, it will be 3 minus 3, which is 0. Buy price for second transaction now becomes 3 again because it is either max or 3 minus 0. And profit of 2 is also 0 with this particular formula because we have either maximum, that is 0, or 3 minus 3, that is prices of I minus buy price of second transaction. Now let's take the previous values handy with us, going to the next iteration or next index. Now the buy price of the first transaction stays same because we have again the price of 3, which is still the same as the previous one. Profit is still 0 because we bought at 3. Maximum what we can do is selling at this particular price, which is 3, so it becomes 0. Buy for second is also 3 and profit for 2 is 0. Now let's come to this wherein the current price is 5. Now we can see from here that we have a profit. My buy price is still going to be 3, which is the minimum that I have seen till now. Profit becomes 2, which is 5 minus 3. Buy price of 2 is the buy price that I have seen or the effective buy price that I will see. The previous buy price was 3 units and the current effective buy price can be prices of I minus the profit that I have seen from transaction 1, which also gives us 3, so this remains unchanged. Profit of 2 now becomes 2, which is 5 minus 3. Moving on to the next index, this now becomes my minimum buy price for the first transaction because it is the lowest we have observed. My profit becomes 2, which is the previous max profit, because if I sell at 0 and I bought at 0, that would give me 0 as profit. Maximum of 2 and 0 is 2. Interesting part over here is the buy price for the second transaction, which is the effective buy price. What happens over here is that previous buy price for second transaction was 3, and for the current transaction, since the stock is at cost of 0 units and I already have a profit of 2 units, so what I am spending is minus 2 rupees because I have extra 2 rupees with me or extra 2 units with me as a profit from the previous transaction. Now the profit 2 becomes maximum of this 2 or maximum of the profit that I have after buying at this particular buy price, which is 2 itself. Continuing with the same. Now this buy price 2 has changed to minus 2. Rest everything is same. Since we have the cost as 0 unit over here, our table is going to stay the same and not change this time. Let's move ahead. When we come to this 3, our buy price 1 is still 0. Maximum profit will now be buying at 0, selling at 3, which is 3 units. Now I had 2 rupees profit from earlier. I need to buy this particular share at 3 rupees. So what I am spending now is 1 rupee for my site in this particular transaction. So the minimum buy price will be either the previous buy price or the current one, which still stays minus 2. Profit now becomes maximum of either 2 or this 3 minus of minus 2, which now gives me a profit of 5. Because this buy price that I had earlier was minus 2. Current sell price is 3. I had a profit of 2. I am now making a profit of 3 from this transaction, and total profit becomes 3 plus 2, which is 5, which is the profit from 2 transactions. Let's move ahead. Over here, our minimum buy price remains the same and all these tables remain the same. When we come to 4, the minimum price over here does not change. The profit of buying here and selling here in this transaction becomes 4. My effective buy price 2 is still minus 2, and my profit now becomes maximum of either the previous transaction or the profit from current transaction, that is 4 minus of minus 2, which is 6. So what this particular transaction means is that I did a transaction that is buying at this 3 or this 3, whichever you want to consider, and selling it at 5, which gave me a profit of 2. And the second transaction was buying at 0 and selling at 4, which is this profit. Adding this 2, we get 6, which is the total profit that we can get. So that was the dry run of this particular approach, wherein we have the formulas with us and the profit 2 gives us the entire profit from at most 2 transactions. So that's all for this approach. I'll want you guys to try to code this particular approach by yourself before going into the coding part with me. So now let's go and code this particular approach out. First and the foremost thing that we need to do is take all the 4 variables. So we'll take C1, C2, P1 and P2. C1, C2 will be integer.maxval and P1, P2 will initially be 0. Now we'll iterate over the array. Now what we are going to do is just update all these 4 variables and finally return P2, which is going to hold the cumulative profit for 2 transactions. Now let's see what C1 has. C1 is the minimum price at which we can buy. So it takes math.minimum of either the price that we have seen or the current price. What about profit? Profit is going to be the maximum profit that I have already seen or the profit from the current transaction. Now the current transaction is selling at this price and buying at C1. What about C2? C2 is the effective buying price, which is also going to be the minimum effective buying price. Effective buying price was calculated using a formula, if you remember, which was nothing but paying with the profit we have got from the first transaction. So that is nothing but cost of current share minus the profit that I have made from previous transaction. This is the effective buy price. P2 now becomes the maximum profit that we have seen in both the transactions. So that is nothing but either P2 or sell price minus buy price. That's it. Let's try to run this code, and it runs perfectly. Let's submit it, and it got submitted. The time complexity over here is O of n, that is same. The only thing is that it is a one pass solution. The space complexity, if you see over here, is O of 1 because we are only taking 4 variables. That's it. So that's it for this question, guys. I hope you like the solutions. Please like, share and subscribe to our channel and drop your thoughts in the comments. And I'll see you in the next one.